Hi everybody, it's 2 a.m. in the morning here, so that seems like an excellent time to continue our video series on 2D development in C#. If you haven't seen the previous video, you should go watch it now because you'll need that for background as to what we're about to do now. So in the previous video we describe what all of this code does here, setting up our viewport and how we render items, but what we're going to do today is structure it so it actually starts to take form of a game. Before we get much further, I want to quickly discuss the kind of elements that we're going to have in our game. So if we imagine this crudely drawn screen is our game, inside of our game we might have our ball and we might have our little player. Let's make a little stickman player. And we might have a floor that he walks on and maybe some other game entities. Now in software development you try to break everything down into a class hierarchy. So all of these elements in the game we're going to call game entities. And everything on the outside, everything contained into the entire world, we're going to call the game world class. So because there's going to be lots of entities, let's create a new folder to contain them all, and we'll create a class inside of here called game entity. Because you can't instantiate an abstract game entity, you have to instantiate a ball or a person or a block. We've marked this class abstract to indicate that. Now the next thing we need to look at is what kind of positions every single game, what kind of attributes every single entity might share. So the most obvious one that we've got here is position. So where in the game world each of these is located. To represent position we're going to use a vector, and the vector vector class is stored in the system.numerics namespace, so we're going to add that now. So our first property that all game entities are going to have is going to be its position. Now if you remember, in our game world the coordinates go from 0, 0 is the top left and increasing going downwards, and so this vector is going to be the same. So if we set the position to 0, 0, then the object would be, the game entity would be at the top left. So that means this guy here would be something like, say, 100 across by 100 down, say. Another interesting property that all of our game elements are going to have is a velocity, because our ball is probably moving in some kind of direction and our person is probably moving in some kind of direction, and we're going to represent that with another vector. And like all good programmers, we put some comments on each of these properties. We'll say that the velocity is in units of pixels per second, because I imagine that will work out quite convenient for our calculations. So that will probably do for the properties that every single entity will have for the moment. Another obvious thing that every entity will need to do in the game is draw itself. So we're going to add a function draw. We're going to leave this function empty for now because things that inherit from game entity should implement draw. Some game entities might not even have a visual aspect to them. They might be, for example, a poison that damages the player as their health ticks down. But if, say, the poison isn't being implemented in the draw function, that means we need some place to implement physics for the entity. So, for example, if this guy is poisoned, or maybe he's thinking about something but it's not changing his drawing, or even just to calculate his velocity. So we're also going to add a game tick function. And in our game tick, because a lot of it tends to be physics orientated, we need to know how many milliseconds elapsed since the last time the tick function was run. For example, if the tick function ran 1 second ago and our velocity is set to 10 pixels per second, then we need to move the position by 10 pixels inside of game tick. We'll add another comment to this. Contain our game logic. Milliseconds elapsed indicates how much game time has passed since this function was last executed. Entities should draw themselves in this function. I think that will do for the moment for our abstract game entity class. We might come back to it a little bit later. And we will move on to the world class. So we'll add another folder, and again we'll call it world. Add new item, and what's a good name? How about we'll just go with game world. Okay, so properties that game world has. The obvious property that game world has off the bat is our game world contains all of the entities. So in this case we've got 1, 2, 3, 4 entities in our world, and because we want our game to have a variable number of entities, like bullets will be getting created and destroyed, monsters spawn, that kind of thing, then the appropriate data structure to use here is we want to use a list of game entities. In our constructor, I might just create a new list because we're nearly always going to want one. Now, we mentioned in the game entity class that we also want to keep track of time. So our game world is also going to include a game timer. I think I'll use the stopwatch class for this because it's a nice, easy one to use. And we'll call that game timer. Actually, we don't want external people to change our game entities list, so we only want that read-only there. Let's construct a new stopwatch as well. I think that's probably all we want on our game world class for the moment. So our game world is just a list of entities, but we do want a function that is add entity, which is responsible for adding entity to a world. It's useful to place this function here rather than just manipulating this list directly, because we might want the world to initialize some kind of memory or perform some startup logic each time an entity is constructed. It might also need to do some locking kind of work if there's multiple threads that are accessing this list. We won't be doing that in this tutorial because this is just a bit of a beginner introduction, so we'll try to keep things fairly simple. But on the other hand, we're also trying to keep things relatively neat and tidy in a way that could be expanded to a more serious game. So for our implementation of this, let's make this very simple for the moment, and we'll just add the entity to the list. The other function we want to do in here is we want to tick every single game entity in our list when our world gets a tick. So let's do something like game tick, and we'll just go for each var entity in game entities, and we'll run entity game tick. Oh, but we need to calculate the elapsed milliseconds. That seems like a useful property of the world as well, so let's add a property here, elapsed milliseconds since last tick. And this is going to be the time elapsed so far, subtract the time it was on the previous game tick. So we haven't stored the previous game tick yet, so we want to do that. And I think we want to work in milliseconds, so we'll go total milliseconds. So the current time, subtract the last time, total milliseconds is the amount of milliseconds since the last tick. So that also means we need to record the time when we last ticked, which will be on our game timer elapsed. And now we can pass in elapsed time since last tick to our game entity. I think that will probably do for our game world at the moment. So let's go back to our main window. And our main window, we now want to have a reference to our game world. And we've got a create world function that we want to call before hooking up our render event, where we actually instantiate the world. Well, you get a lot of power as a game developer. You get to create and then destroy entire worlds. It's probably part of the reason people are into game development. So that looks cool. If we in create world, it would be nice to add entity like new Mario Brothers guy, that kind of thing. Unfortunately, because we're not making a cool Nintendo game, we're probably going to end up with something like new ball, because that's the level we're at now. We're not professionals working at Nintendo as yet. In our composition target.rendering event, you remember this gets called 60 times a second, so this seems like a pretty good place to call our game tick. So that would run all the logic on our entities. So remember, game tick loops through all our entities and calls tick on everyone, allowing them to move, physics, cause poison damage, that kind of thing. The other thing that we need to do in here is we also want to do our drawing. So let's go for each game entity, in world.gameEntities, entity.draw, and we'll pass it in the writable bitmap. Oh, we've made a mistake on our entities class. We actually should have had what's often referred to as the surface, which is what you draw on. To recall, our writable bitmap gives us functions like draw circle, draw line, that kind of thing. So if we wanted to make a game entity that was a line, we could do so here. Back to game world. One might wonder why I didn't implement this drawing loop inside of the world here. One of the reasons is that we generally don't want to have our game entities and game worlds reference specific drawing technology if possible. I'm probably going to do that here because it's a bit faster in that we're referencing specific drawing technology there, but ideally you wouldn't, so that you can say swap between using DirectX or OpenGL or perhaps some other kind of game library. That would be something to think about when you're writing your own game, but at the moment we'll try to keep code relatively free of drawing code if you can. If you did want to implement it differently, you could probably implement something whereby game entity exposes a texture and then something else is responsible for drawing the texture at the correct position, like, and you'd call that a renderer. But getting a bit off topic now, so I think that's as much as we want to do there. And at the moment, because our world contains no entities, if we run this, we basically just end up with a blank screen, which isn't the most fascinating. So just to make sure that we've actually achieved something, let's create a very basic entity, and we'll call this entity ball. And our ball is going to inherit our game entity, and we are going to implement our draw function. One interesting thing here is on game entity we've got position, but our ball also has a radius in addition to a position, so we're also going to add a new property, radius. To draw our ball, we are just going to call surface.draw, fill ellipse, and we're going to go from position.x, position.y, and then the same thing again, but increased by our radius times 2, so we don't have to times things by 2. Let's say that that is the diameter instead. I imagine that, and is there an overload that takes color? System Windows media.color. So we want to import system windows.media, colors dot, let's go with blue. Blue is a nice bold color. Now imagine this is complaining about float in, and it is. Let's just cast these directly over to, we don't want that, to integers for now. It might be useful to create overloads of some of these drawing functions that do take floating points, so you're going to run into this situation a lot. Generally you want to keep the vectors as floats or doubles because otherwise you lose precision. Like if something's moving slower than 1 pixel per second, then we'd end up with a 0.5 in the position, and we want that because it might not increment an entire pixel per tick, but casting it to an integer sort of sorts that out. We could probably do something a little bit better there, but this will probably work for us at the moment. That's all for our drawing function on our ball, but the next thing we want to implement is our game tick function. Now our game tick function is going to be very simple in that it is just going to update our position based on our velocity. I believe we mentioned before that our velocity is in pixels per second, so that means that I'm going to increase our velocity by, if milliseconds elapsed was 1 second, then we'd want to multiply our velocity just by 1. So if 2 seconds passed, we'd want to move 2 lots of velocity. But because this is in milliseconds, we also need to divide that by 1000. We should now be able to add our ball entity to our world. So in create world, let's go bar ball equals new ball, and we'll set our diameter to say 10, our position to 100, 100, which will be in the middle of the screen somewhere, and let's give it a velocity, let's say 60 pixels a second, because that fits in with our frame rate relatively well. 60 pixels per second towards the bottom right, and then we want to go world.add entity and ball. So now our world contains a single ball which is going to go to the start at 100, 100 and head towards the bottom right. Well, hopefully. Usually we don't get these things right the first time. So let's give that a quick run, see what we see. Oh, there's our ball, but for some reason it's not moving anywhere. That means maybe our game tick function didn't work. Let's put a breakpoint there. On the upside, our drawing function worked okay. So we'll step into game tick, and elapsed millisecond since last ticked is 0. Oh, I see the problem. We've never started our game timer, so we also want to add a function on here, start timer, and we'll go game timer dot start. Back in main window, we'll go how about just after we've created the world, we'll go world dot lowercase start timer. See if that fixes our issue. Oh, and there we go. We've got our ball moving and our game tick is increasing its velocity. At the moment there's no collision detection or anything like that, but that's something we're going to add on in our, we're going to look at in our next video. I'm trying to keep these relatively short, just to demonstrate that we can add more entities to our world. Let's copy and paste this one really quick and call it ball2, and we'll start it in a different position, and we'll make it go in a different velocity, and we'll run that. We should see 2 blue balls going at once. Oh, we didn't add our second ball. And there's our second ball. So we can now add as many balls as we like, which is a good start to our game. In the second video, I'm going to look at collisions between entities, and then we're going to progress towards making a simple kind of, I was thinking a bat and ball game, but maybe we'll do a platformer where you control a ball. I'm not really sure yet, so I guess we'll see. Anyhow, thanks for tuning in. Check out my other videos and have a good day. Cheers.